we're going to talk about what we call this lesson 8.3, which actually came from a different book, but we feel that it's very useful, and this is actually going to teach us how to find horizontal, vertical asymptotes, x and y intercepts, respectively. So this is actually has a lot of stuff that is very useful for you. Now remember, if you're doing this on your own, meaning if you're just writing notes, you perhaps don't need to write every single thing that I write up here, but because we're going to go over it at the bottom. Okay, now when we talk about a rational function, but if you printed out those copies, I would say go ahead and copy this down. We are just basically talking about a function that has the form of a function divided by another function. Okay, so again, p of x and q of x are both functions. They can be any function again, right? So the only thing that it can be is you cannot have a zero on the bottom, and hopefully that's obvious. Now, to find the y-intercept, not only in this really, but in any type of function, you're gonna set the x coordinate equal to 0. Okay. Now to find the x-intercepts of the graph, you are gonna have to set the numerator equal to 0. Now to set the numerator equal to 0, really at this point is the same thing as setting y is equal to 0. But you're gonna see what I'm talking about here in just a second. Now to find the vertical asymptotes of the 0, we're gonna set the denominator equal to 0, and we're going to solve for x, okay? Now the graph is going to have at most one horizontal asymptote. And if there is one, okay, it is determined by the highest exponent of x if the function looks like this. Now, this is for the most part the stuff that you really need, and again, you don't need to write every single word if you're writing this in your own paper, but you definitely need to write this, okay? And then I'm going to go over and tell you what it means, all right? So to figure out the horizontal asymptote, all right, these are called the horizontal asymptote rules. Okay, if the exponent of the numerator is less than the denominator, and on this one really we're talking about the power. If the power of the function, all right, which remember that's called the degree of the function. If the degree of the function is less than the degree of the denominator, then you have y is equal to 0. All right, hence this is what I call BOBO, bigger on bottom, y is equal to 0. All right, so that basically tells you what the horizontal asymptote is going to be. Now remember, it doesn't matter what the equation is, as long as the degree of the numerator is less than the denominator. If it's bigger on the bottom, you have y is equal to 0. On the second one, if the exponents are the same, then we're going to use this rule called Betsy, right, where we say bottom equals top, and we're going to go with the ratio of the coefficients. And I'll show you what that means here in just a second. Or I'll give you an example, even if I don't have one on here. Right, finally, we have both two, right? If we have bigger on top, the horizontal asymptote is undefined. And for the most part, what that really means is that you're going to have this, you're going to have what's called perhaps a slanted asymptote, but in algebra 2 we're not really going to worry too much about the slanted asymptote, right? We're just going to, if the degree of the bottom is bigger, if the degree of the top is bigger, then we're going to have always the horizontal asymptote will be undefined. And again, if that doesn't make sense, that's okay, just make sure to write those three, and let's just go over a few examples, right? So we're going to have to graph this, and we are going to graph this in the calculator, but we're going to ask you a few questions that you should be able to figure out, right? If I want to find the y-intercept, I'm going to set the x equal to 0. So if I set the x equal to 0, I would get 4 over 1, which is just 4. Okay, so my y-intercept would be 4, 0. So 4, 0 would be, let's see, 1, 2, 3, 4, right there. That's my y-intercept. My x-intercept, I'm going to set the numerator equal to 0. And in this case, really, that's the same thing as setting y equal to 0. Okay, so, and if that happens, I'm just going to set that equal to each other. And in that case, 4 is never going to be equal to 0. So there's actually no x-intercept. Okay. Now, to find the vertical asymptotes, we're going to set the denominator. In this case, the denominator is x squared plus 1 equal to 0. Okay, and then we're going to try to solve for the vertical asymptote. Now, the vertical asymptote in this case, right, if I subtract 1 from each side, and then I take the square root, remember, this is actually x is equal to plus or minus I. So it's imaginary. And if you really do get an imaginary, then you are not going to have vertical asymptotes, right? So this one actually doesn't have any vertical asymptotes. And then finally, the horizontal asymptotes, right? So we're going to look at this equation one more time. We're going to talk about what that means. The degree of the bottom, remember, the degree is the highest power here, is 2. Now, the degree on top, you can actually, if it's just a constant, you can say is degree 0. Okay, so which degree is bigger? Which one has the biggest power? All right, this one has the biggest power, so it's bigger on bottom, which is the one we call Bobo, right? And if it's that, then the horizontal asymptote is y is equal to 0. Okay, so about the only two things that we know for certain is that we have a y-intercept of 4, and that we have a horizontal asymptote at y is equal to 0, which is the horizontal line. Now let's go ahead and take a look at it. It could be a weird function, not really sure yet. But we're going to go ahead and put it on here. And then we're going to see what this looks like. Now you can type it in like this, or press alpha y equal to do the subtraction. That's what it looks like. Okay. So notice again that I think it's really hard for you to see the color, but it gets really, really close to the horizontal asymptote, right? But it actually never crosses it. So we're just going to sketch that real quick. There we go. And then we're going to get really close, and that's it. Okay? Alright, let's go on to the next one. Now we're going to do the same things. We're going to look for the y-intercept, the x-intercept. So to find the y-intercept again, set the x equal to 0. So in this case, we have 2 times 0 squared over 0 squared minus 9, so that's going to give you 0 over negative 9, which is still going to be 0. Okay. Now for my x-intercept, I'm going to set 2x squared equal to 0. Now, some of you hopefully already know right away, well, that x is going to have to be 0, right? But if you don't know, you can go through the steps, divide by 2, you get x squared is equal to 0, and if you take the square root of 0, you get 0. Surprise. Okay. So both my x and y-intercept are basically at the origin. Alright, so x and y-intercept are both right here, right at the origin. Right, to find the vertical asymptotes, again, we're going to set the denominator, in this case, equal to 0. And then we're going to solve for that. Okay, we're going to add the 9. And then we're going to take the square root of each side. Now don't forget, when I take the square root of 9, I get plus or minus 3. So in this case, I actually have 2 vertical asymptotes. I'm going to go ahead and put them up here. Okay, so let's see, we have one at negative 3, one at positive 3. Okay. Okay, there's that. And then now, I'm going to go ahead and try to find the horizontal asymptote. Now this one, I think it's a little bit easier to look at. A little bit easier example, right? Now look at the numerator up here. The biggest power here is 2. And if you look at the bottom, the biggest power with the variable is also 2. So the powers are the same. So in this one would be bottom equals top, which is the coefficients. In this case, is the ratio of the coefficients. Alright, so when we talk about the ratio of the coefficients, what I mean is, go to that x squared, see what number is attached to it. In this case, it's a 2. And then we're going to divide that by the coefficient of the number that's attached to this x squared. Now, if you don't see a number here, that's actually just a 1. Right? So we have 2 over 1, which is 2. So in this one, the horizontal asymptote for this one would be y is equal to 2, which is up here. Okay? Now let's go ahead. Now this is the only information we got. Let's just see what this would look like on a calculator. Alright, so I'm going to put that up here. Hopefully that's not too much in your way. I'm going to go to y2 for really no reason whatsoever. If you want to look at it as a fraction, press alpha, y equal. Press enter now. So we have 2x squared over, I believe it was x squared minus 9. I'll check it out here before I graph it. Let's graph it. Alright, there is that. There is that. And there is that. Okay. Now, notice that what's going on here is that you do have a vertical asymptote right here at 3. You have another one at 3. And, I mean, I can actually graph for you the horizontal asymptote. I can't do that with the vertical. But this blue line, if you can kind of see it, this actually would represent, in this case, a horizontal asymptote. Okay, so, but that's not really there, so I'm going to go ahead and delete that. So that's what it would look like again. Okay, so if you're graphing this, if we're just doing a sketch, just get really close to both of those. Get really close to both of those. By both, I mean both asymptotes. And then finally, let's just do one over here. Let's see, is that one right in the middle? Yes. Alright, so we're just going to do this. Alright, that's it for that. Okay, let's move on and do the next example. Alright, so on this one I'm going to go through a little faster. If you kind of get it, you may want to fast forward, or at least fast forward as I'm talking here, so you can get through it faster. But in this case, if I set every x equal to 0, okay, that would give me 0 here, 0 here, and I would end up with a -3 on the top. Now on the bottom, if I plug in a 0 here, I end up with a -4. So in this case, my y-intercept is positive 3 over 4. Okay. Now for my x-intercepts, all right, for my x-intercepts, I'm going to set the y is equal to 0, which basically all I have to do is set the numerator equal to 0. Now to solve this one, if you don't remember, if you have a quadratic function, you have to factor. All right, so I'm going to have to factor. I need factors of -3, that up to -2. One has to be negative, one positive. Remember, that's because if this is a negative number, and that means that how you get a negative from multiplying a positive number. In this case, it's going to be a 3 and a 1. All right, -3 times positive 1 gives you -3, and -3 plus 1 gives you -2. All right, so now I'm going to set each factor equal to 0, and I'm going to solve. This one is x is equal to 3. This one is x is equal to -1. Okay. So in this case, I have two x-intercepts. I have one at -1, one at +3. Right now I have a y-intercept at 3/4, so right about there. Right, finally vertical asymptotes. I'm going to set my denominator equal to 0. That will give me x is equal to 4. Alright, so I have a vertical asymptote at 4. In this case, it's about right there. Okay, now my horizontal asymptote, there's my vertical asymptote, my horizontal asymptote, you don't have to copy it down every time, I'm just trying to make it easier for you to look at. Now, look at the degree of the top. The degree of the top is 2, excuse me. Okay, the degree of the bottom is 1, remember, because that's x to the power of 1, okay? Which one's bigger? The top one, right? So if the top one's bigger, we have bigger on top, it's undefined. Okay, so meaning there is no horizontal asymptote. Okay, there might be a slanted one, and we might be able to see it here when we graph this. Alright, so we're going to go ahead and move this over here so you can see it. So I'm going to quickly type this in. Okay, so let's see, we got x squared minus 2x minus 3. Oh, I'll write that as a fraction. X squared minus 2x minus 3 over x minus 4. Okay, so now we're going to go ahead and graph this. I'm going to put my calculator over here so you can see it. Now that's what I meant. Even though you don't have a horizontal asymptote, you can definitely tell there is some kind of slanted asymptote here. So what I mean by that is that it looks like there is an asymptote that kind of goes like this, all right? Now there is a way to find that, but we're going to leave that to your pre-calc teacher for next year. All right. Now let's go on to this one right here. The last equation that we have to graph, same thing. Y-intercept, set the x equals to 0. That will give me 0 over negative 4, which is 0. So that's my y-intercept. Right, my x-intercept, we're going to set my numerator equal to 0. And if I take the cube root of each side, I will still get 0. So both my x and y-intercepts are right here, which means they're at the origin. While in the vertical asymptote, we're going to set the denominator equal to 0, so we have x squared minus 4 is equal to 0. And hopefully do the same thing, add the 4, take the square root, you're going to get plus or minus 2. Okay, so let's go ahead and do that. So we have plus or minus 2. Right, on this one, right, we have that is the degree of the top is bigger than the one on the bottom. So again, if you go back to this, right, bigger on top is undefined. So it looks like we're going to have some sort of other slanted asymptote. So again, we have both 2. So in this case, the horizontal asymptote is none. So there is no horizontal asymptote. We're going to go ahead and graph this one real fast to see what it looks like. So we have alpha y equals x cubed over x squared minus 4, and then we're going to graph it again. And on this one, you can definitely see there's some kind of slanted asymptote. It's a crazy looking function for sure, but it basically is going to do this, and it's going to do that. And I don't really have those points. I guess I can look to see if I have any points that are not terrible, but they're all pretty terrible, so I'm going to leave that alone. And I'm just going to do my best and try to sketch this, okay? So you can do the same too. The point here is not to get a perfect graph. The point here is to try to figure out how to find horizontal and vertical asymptotes and x and y intercepts. And if you can do that, you're golden. All right. So on this one, it's asking you to write an equation for the graph that has 2 vertical asymptotes. One at x is equal to negative 3, one at x is equal to 2, and it has 1 x-intercept. Okay. Now, it kind of helps if you just even look at the equation above, right? How did we get the vertical asymptote? We set the denominator equal to 0. And as a matter of fact, if we look at a problem like this, it might even help even more, right? If I factor this equation and that equation are the same, okay? So what I can do, right, getting that equal to negative 3, originally I had this equal to 0, so that means that I had an equation that had an x plus 3, right? Because if I set that equal to 0, I'll get x is equal to negative 3. And I had another equation where x is equal to 2, which means that this would be x is equal to negative 2. All right, so this is, if it's a vertical asymptote, this is actually in the bottom of a fraction. Think about it, all right? Now I go backwards. If you don't believe me, right, set this equal to 0 and solve, and you should get those two. And then finally it has an x-intercept that x is equal to 1. Now remember, where did the x-intercept come from? You set the numerator equal to 0. So if I set the numerator equal to 0, that must have meant that I would have some equation that looks like this. X minus 1, if I set that equal to 0, I would get x is equal to 1. So this is one way that you can write the equation for a graph of a rational function.